Hello everyone. We are all legacies of our past. People from around the world look, think and behave differently because of their different ethnic and cultural pasts. And the same applies to communities of plants and animals from different parts of the world, which can look and behave very differently even when they occur in similar environments because of their different evolutionary pasts. And this is shown by the world's most important group of animals. And that's right, I am talking about ants. Ants are wonders of nature. They're a family of social wasps, not to be confused with termites, which are social cockroaches. Now, if you collected every single creature on land, ranging from tiny insects to elephants, and you weighed them, ants would represent 1/5 of that total weight, weighing in at more than all the wild birds and wild mammals combined. So ants might be small, but there's an awful lot of them, and an awful lot of species, 30,000 or so. Ants play crucial roles in virtually all terrestrial ecosystems. They are the little rulers of the natural world. So here in Darwin, we're in Australia's seasonal tropics. When most people think of the tropics, they think of rainforest. But rainforest only occurs when there's water available all through the year. And in most of the tropics, that is not the case because rainfall is highly seasonal, with months on end with no rain at all. And here, the trees are sparse and the ground is covered in grass. That's what we call tropical savannas. The world's largest continuous estate of tropical savanna occurs here in northern Australia. All 2 million square kilometres of it, with only a tiny fraction cleared. So Brazil's best known for its Amazon rainforest, but it has a similarly vast area of savanna, even though most of it has been cleared for agriculture. Now guess where the highest diversity of ants is found? It's here in Australian tropical savannas by a long way. But if you ask most ant specialists, they'll tell you that peak ant diversity occurs in tropical rainforest, and especially in the Amazon, where there's 2,000 species of ants. But that's not right, because it's only considering described species, that is, species that have been given a formal name by taxonomists, whereas the vast majority of species in Australian savannas are not described. We've shown that for every described species, there's dozens, if not hundreds, of undescribed species. And we're still not totally sure how many ant species occur in Australian savannas, but it's got to be at least twice as many as in the Amazon. So the Australian savanna ant fauna stands out because of its unbelievable diversity. But it stands out in another way, and that is throughout its entire evolutionary history, virtually its only land connection has been with arid environments to the south. And it's these arid environments is where the savanna ant fauna, to a large extent, has come from. And the savanna ant fauna is very similar to the fauna from Australian deserts. It's an arid adapted fauna. And in total contrast, Brazilian savanna has been surrounded by rainforest throughout its evolutionary history, and that's where its ants have come from. It is a forest-derived fauna. One way this is shown, this functional difference between the savanna faunas of Brazil and Australia, because of their past evolutionary association with functionally different ecosystems, deserts, tropical rainforest is through the distribution of harvester ants. These are ants that eat seeds. So as social wasps, the ancestral condition of ants is one of a predator. So eating seeds is very unusual, and only a few groups of ants can do it. And they're found mostly in arid environments where seeds are such an important food resource because vast numbers are produced when it rains, and they can be harvested and stored for long periods between rain. Arid Australia has a vast number of specialist seed harvester ants, and they are incredibly abundant. Harvester ant abundance and diversity is also extremely high in our tropical savannas. Hundreds of species of them. And how many harvester ant species are in Brazilian savannas? One. So that's a legacy of an evolutionary association with rainforest, which does not have harvester ants. Another example is with ant species that can tolerate extremely high temperatures. We call them highly thermophilic. And Australia has by far the most diverse genus of highly thermophilic ants. The genus is Mellophorus. I've collected over 1,000 species of Mellophorus, and there's probably 2,000 altogether. Now, for most ants, peak foraging activity occurs when the soil surface temperature is about 35 degrees. And once it gets more than 40 degrees, most foraging stops. It's just too hot for them. But this is when foraging Mellophorus just starts cranking up. And their peak foraging occurs at 50 degrees Celsius, and it never gets too hot for them. There are hundreds of species of Mellophorus in Australian savannas. And how many species of similarly thermophilic ants occur in Brazilian savannas? None. And again, a legacy of a past evolutionary association with rainforest. So the savanna ant faunas of Brazil and Australia are functionally very different because of their different legacies of their evolutionary pasts, one in association with deserts, the other in association with tropical rainforest. And an important way this is expressed is through patterns of diversity in relation to rainfall. So here in Australian savannas, we have a rainfall gradient running from more than 1,500 millimetres a year at the northern coast down to about 500 millimetres a year on the fringe of the northern arid zone. And for most groups of plants and animals, there's a marked decline in the number of species as you go down this rainfall gradient, but not for our arid adapted ants, where 100 or more species per hectare occurs all the way down the rainfall gradient. This pattern is not found in any other ant fauna. And as you might expect, a forest-derived fauna is sensitive to declines in rainfall, and that's the case for patterns of diversity in relation to rainfall in Brazil. There's a marked decline in ant diversity in Brazilian savannas with declining rainfall. And all this has important implications for the likely responses to the declines in rainfall that are projected under climate change. Such declines in rainfall are not likely to affect Australian savanna ants, but they're likely to cause a marked decline in the diversity of ants in Brazilian savannas. So that's a good news story in climate resilience for Australian ants, not so good for Brazil. And I think there's an important lesson here for humanity as we grapple with the climate crisis. We want to build a resilient future. Now is the past of the future, and what we do now will create the legacy for how resilient we'll be under a future climate. So climate change is locked in over coming decades. We can't change that, but what we can do is prepare for it. We can prepare for growing food under increasingly arid conditions. We can prepare for our coasts to be eaten away by rising sea levels. We can prepare for the increased risk of catastrophic floods and mega fires. Under a future climate, we want to be resilient, just like Australian savanna ants. So next time you think about the amazing diversity of people and their different legacies of the past, I hope you'll be reminded of the amazing diversity of ants from around the world and their different legacies of the past, and what that can teach us for building a resilient future. Thank you.